Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be answering a question from a Test Your Understanding of P2 Chapter 6.6 Trig Identities and Equations. This is question 3, part A and B, and the student has asked me to go through this question, so I will do so. Now here in this question, we are asked first in part A to show that 3 sine x tan x equals 8 can be expressed as 3 cosine squared x plus 8 cosine x minus 3 equals 0. So we have to start with 3 sine of x times tan of x equals 8 and re-express it in this form. Now, when you start with a question such as this, sometimes you can't see how we're going to get to the answer directly. So you have to take steps, step by step. So if we look at this expression, there's not really much we can do apart from thinking of the identity that the tangent of an angle is equal to the sine of the same angle divided by the cosine of the same angle. So what we can do here is we can replace the tan x with sine x over cosine x. That's one thing we can do here. That will help in this particular question. All right, that might be a way for us to continue. So we have 3 sine x times sine x divided by cosine x equals 8. And this will now lead us to, basically, there will be sine x times sine x, which is 3 times sine squared x over cosine x equals 8. Because sine x times sine x times sine x is the same as, you could think of it as sine squared x, but sine squared x is written in this format. That means the same thing. That means sine x multiplied by itself, sine x all squared, but we write it as sine squared x. Okay, now here we have something where there's a fraction, so if we multiply both sides by cosine x, that will get rid of the fraction. Okay, that will get rid of the fraction, and you're left with 3 sine squared x equals 8 cosine x. So now we're kind of looking like we're getting closer, but you see what we have here is just with the cosine x ratio, cosine squared x, cosine x. So what we could do here is we can use our other identity that we know, which is sine squared x plus cosine squared x equals 1. And we can replace the sine squared x with 1 minus cosine squared x. So sine squared x is the same as 1 minus cosine squared x, because if we rearrange this, you have sine squared x is 1 minus cosine squared x. So I can replace the sine squared x here with 1 minus cosine squared x equals 8 times cosine x. Now, many people make a big mistake here. They think we can change the cosine x for 1 minus sine x. But you can't, because it has to be squared. Okay, sine squared x plus cosine squared x equals 1 does not mean that sine x plus cosine x equals 1. That's not true. Okay, that's not true. Okay, it's not equal to 1. Okay, that's a mistake. It's just like 3 squared plus 4 squared equals 5 squared. It does not follow from that 3 plus 4 equals 5. We know that's not true. Although 9 plus 16 equals 25, that's true. This is not true. 3 plus 4 doesn't equal 5. So when you have something like this, which is a sum or difference of terms which are squared separately, you cannot just take the square root of each of them and make it equal to the square root of the other side. That doesn't work, as you can see here. So we can only replace the sine squared x with 1 minus cosine squared. The one that's squared can be replaced by 1 minus the square root of the other. Okay, not when it's not squared. So that's one place where many people make mistakes. So the next step here, we can expand the brackets. So we have 3 minus 3 cosine squared x equals 8 cosine x. And we're almost there now, because we see we had to end up with 3 cosine squared x plus 8 cosine x minus 3 equals 0. So we could basically just add everything, add 3 cosine squared x to both sides. So you have 3 cosine squared x, and this will be already there, plus 8 cosine x, and subtract 3. You're left with this, so just write it in the same format on this side. So 3 cosine squared x plus 8 cosine x minus 3 equals 0. If 0 equals this, then this equals 0. So we have now shown what we had to show. So that's part A. Now for part B, it says hence solve the equation. Now the word hence means using what we have just found. And if you compare, you always see a link between what you have done in part A and part B. Whenever you see the hence, there's always a link to what's done earlier. So these two, you can see they're almost the same. They're almost exactly the same. The only difference being, now we have, instead of x, 3x. So basically, I can rewrite this in the same form as that, which is something I can solve, except instead of the x, I have to write 3x. So I can write 3 sine 3x times tan x, 3 sine 3x times tan x, okay, equals 8. I can rewrite this as 3 cosine tan 3x, sorry, 3 cosine squared 3x, okay, plus 8 cosine 3x minus 3 equals 0. I can rewrite it in this form because the x that we have here has been replaced by 3x. So if it's true that this is equal to that, okay, then you can say that this is equal to the same thing but with 3x instead of x. That's all, because we replaced the 3x. The x has been replaced by 3x, so this x has also been replaced by 3x, and everything else will be the same. So now I need to solve this equation between 0 and 2 pi. For x values between 0 and 2 pi. Okay, so first thing what I'm going to do is I'm going to recognize this as a disguised quadratic equation, because you have something squared and the same thing not squared, like cosine 3x. So for example, I can choose a letter like u and say let u equal cosine of 3x, in which case u squared will be cosine squared of 3x. So I can replace this with 3u squared plus 8u minus 3 equals 0. Now we have to factorize this expression. So what I can do is I can take my 3u squared over here and my minus 3 here. I'm looking for a product of minus 9u squared and for a sum of plus 8u. It looks like it's going to be plus 9u and minus 8u. Okay, they add up to give you plus u, sorry, not 8u, plus 1u, plus 9u and minus 1u, sorry. 9u minus 1u is 8u, and 9u times minus u is minus 9u squared. So now I can take out my common factor from this row, which is u. U times 3 is 3u squared. U times 3u is 3u squared. U times minus 1 is minus u. And 3u times plus 3 is plus 9. So I'm left with 3u minus 1 times u plus 3 equals 0. So we got u equals 1/3 and u equals negative 3. So we can now say that our two solutions are, we called cosine x u, 3xu. So we're going to have cosine of 3x equals negative 3 and cosine of 3x is equal to 1/3. Now as for cosine 3x equals negative 3, well, the cosine curve will never reach negative 3. Okay, the highest it goes is 1, the lowest it goes is minus 1. Even if there's a 3x here, that just affects the x values. It's kind of like, you know, the curve is like stretched horizontally by a factor of 1/3, so it doesn't stretch vertically that way. If I try to solve this using my calculator, I'll get maths error. So this gives us basically no solution. No solution. As for cosine x equals 1/3, of course, we're going to have some solutions. Now we can say 3x equals inverse cosine of 1/3. That will give us our first solution, which is called the principal solution. Okay, we have inverse cosine of 1/3. Okay, that gives us the solution 1.2309. Okay, so 3x equals 1.23095. It continues on. Now, one thing we have to be careful of here is the fact that our limit says 0 between x and 2 pi. Okay, now we're solving for 3x. So when you have a multiple angle in here, whatever's written in here, the same thing must appear over here in our limit. So I have to make this into 3x, which means I need to multiply by 3. Therefore, I multiply every part of the inequality also by 3. So the 0 times 3 is still 0, but 2 pi times 3 is 6 pi. Which means we've got to collect all the answers between 0 and 6 pi. Okay, and here's our first answer, which I'll store as A. Now, 6 pi is equal to 18.85. So 18.85. That's as far as we can go. We can't go more than 18.85. All right, so I've got to find all the solutions between 0 and 6 pi or 18.85 radians. Now, this is our first solution, which we just found. Our other main solution is going to be over here, which is going to be 2 pi minus this angle. So we're going to take this angle and we're going to subtract 2 pi from it. So our angle was this 1.2. 1 second. Our angle was this. That was our angle 1.23. So we're going to do 2 pi minus the angle. That gives us our other main angle, which is 5.0522. Okay, now from these two angles we can generate all the other solutions, all the way from there to 6 pi. You see there's another solution here and another there. This solution is 2 pi further on from this, and this solution is 2 pi further on from this. So what I need to do is keep adding 2 pi's to all of these to get my other solutions. So I'm going to take this answer here and I'll add 2 pi. And that gives me 11.335. 11.335. And then I'm going to add another 2 pi. Okay, let's see where that takes us. And that gives us 17.61, which is still in our range. Our range goes up to 18.85. So 17.619. 17.619. That's in our range still, but it has to stop there. And this series of solutions, which will give us, let's go back. Okay, that was our first solution. So I can add 2 pi to this. And it gives us 7.514. 7.514. And I can have another solution. I don't have to write 3x again. Okay, the next solution, I have to take this and add another 2 pi. That gives us 13.797. 13.797. And if I add another 2 pi, I think I'll be outside of the range. Plus 2 pi. That gives us 20.085. So here we have these solutions, all of these solutions, but they're all in terms of 3x. I want them in terms of x. So I'm going to take each of these values and divide them by 3. Okay, so let's take this. Well, this was outside of the range. Let's take the ones that we got in the beginning. We started off with 1.23. Okay, divided by 3 gives us 0.410 to 3SF, I think it says. Okay, it doesn't tell us how to express it. So if it doesn't say so, we should always do 3SF. So that gives us, as we said, 0.410. That's 3SF. And the other solution, I'll do them in order, 5.05. Okay. Did we get that here? I'll just put it in here. 5.0522 divided by 3. Divided by 3. 1.68 to 3SF. 1.68. And then I'm going to take 7.514. 7.514 divided by 3. That gives us 2.50. And then we're going to have 11.335 divided by 3 gives us 3.78. And then we're going to have 13.797 divided by 3. And that gives us 4.599, which is 4.60. And then finally we have our 17.619 divided by 3, which gives us 5.873 SF. So those are all the solutions within our range from 0 to 6 pi, or from 0 to 2 pi in the end. Okay, when you divided them by 3, we end up with our answers, and all these answers are in our range. And if we had not multiplied our range by 3, we'd have lost many of these solutions. Okay, so that's how you deal with this question. When you have a multiple angle here, whatever's here, they must match it, so must the limits, and then you must get all the angles up to that limit, and then in the end make this into x, divide the answers by 3 to get your answers in terms of just x. So that's the answer to this question. I hope that was clear. Thank you for watching. You'll find other questions you might want to see answered from the Test Your Understanding in the list over here, in the playlist that will appear over here, and other questions from trig identities and equations from P2 you find over here. And if you want to see other stuff from my channel, you can click on the link that will appear in this area. Thank you for watching. See you soon. And